Hello, astronomy students, and welcome to week 2, where we're talking about the ecliptic. The week 2 assignments are kind of split. There's sort of a end of week 1, beginning of week 2, and then there's the end of week 2. It's all moving pretty quick, so you need to keep on pace. I recommend getting started on this stuff as soon as you can. The first part of week 2 involves the sun's motion from sparks throughout the year. The first part of this involves checking out a tutorial on the sun's motion through sparks, and the second part is this, focusing on the ecliptic. The ecliptic is a really important line in our sky, and it denotes some very important stuff for us, and I'm going to go over that right now. So, what is the ecliptic? Hopefully you've already watched the tutorial on the sun's path and how it changes throughout the year. If you haven't, I would stop this presentation, go back and watch that tutorial. Moving on though, once you understand a little bit about the motion, there's some things we need to clarify, and the ecliptic really helps. So if we look at the path, the dome of the sky that we can see, right? This is one way of representing what we're able to see from any given spot. The tutorial on the sun's path has us looking south. Many tutorials have us looking north. This is kind of a third-person perspective, seeing what someone could see from any given spot. Imagine you're standing in the middle of a field that's flat everywhere. This would be the dome of the sky that you can see, with north, east, south, and west all spread around the horizon there. We talked about this a bit in class a couple of days ago. The sun's path in spring and fall, again from the tutorial, rises directly in the east, goes relatively high in the sky in the south, and then sets in the west. Again, if you don't understand this, watch that other tutorial. Now, the sun, of course, is making a complete circle as it does this. We just only see part of it, but the sun is making a circle almost 360 degrees every single day. It is not, in fact, 360 degrees, though. It's just shy of it. It's about 359 degrees that it makes around every day. So it loses just a little bit. And this actually becomes really important in what we have going forward. But we'll get to that in a little bit. So, of course, as we also talked about, this is the sun's path in the spring and fall, but here's the sun's path in the summertime. In the summer, the sun rises north of east, goes relatively high in the sky, and sets north of west. This is what the sun will do on the summer solstice and throughout June and July. Well, this is a very different position than where the sun is during the spring and fall. It has to get from one spot to the other. Not only that, when we talk about the winter, the sun's path in the winter rises south of east, doesn't go very high in the sky, and sets south of west. It also has to get here. And so how does the sun get from one position to another as it moves along this path? So if we track the sun day to day, we actually see something really interesting. Like we mentioned before, on any given day, the sun will rise somewhere in the east, go up somewhere in the south, and set somewhere in the west. So imagine we're looking at the sun on the September equinox at about 9 a.m. We'd expect it to be somewhere south of east and a little bit above the horizon, working its way through the sky. Well, let's say we come back a day later at the exact same time and see where the sun is. Well, if we look for the sun on September 22nd at 9 a.m., we'll see its position will be slightly different. It'll have shifted a tiny little bit to the right and a tiny little bit down. If we come back on the 23rd at the exact same time, the sun will be here, over and down again. The 24th, over and down again, and on and on. The sun slowly works its way down and down and down for a while, and then it starts working its way back up and to the right. It's confusing, but this slight little bit of difference is really, really important, and any good caveman would have noticed it. But it's hard to see from this model, so let's take a look at a different view. So let's take a little bit of a different view using the Stellarium web app on our desktop. So with the Stellarium web app here, by default it shows me nighttime, and that's okay. We'll change that in just a second. We got to remember we're also looking north, which isn't where we want to be looking when we're talking about the sun. So let's drop in our azimuthal grid. This is going to help us. And then let's start setting this to a time when we'd actually have the sun in the sky. Right after we turn southwise. And now we're looking kind of like the model tutorial has. We're looking at the southern part of the sky. Okay, so now let's look at changing the time. So instead of 8 o'clock p.m., let's run that back to, I don't know. Let's go to 9 a.m. like we were talking about before. So if we work our way back to 9 a.m., we see the sun going through our sky. And there we are at about 9 a.m. And let's go to the same date that we were talking about. We'll go to this. So we'll change it to the equinox sun at 9 a.m. Now, I don't know about you, but for me, it's a little hard to see the sun here. So what I'm going to do is I'm going to turn off my atmosphere. So now I'm seeing my sun and the background stars behind it. Now the sun's really clear. Obviously, this is an unrealistic view. We wouldn't see those other stars during the day. But just like we noticed before, if we go ahead and start cranking on the day here and changing it one day at a time, we see the sun slowly changes position, dropping itself down and to the right every single day. And so we'll see that every day. We're looking at the same time, but the sun continues to drop itself down and to the right, exactly what we were seeing before. This is a little hard to understand, and the thing that helps us understand it is by looking at the ecliptic. So I'm going to go ahead and open up the ecliptic here by changing my view settings and see the ecliptic line. There's my ecliptic, and I say close. And you'll notice this ecliptic line runs right through the sun. And so if we watch the sun again, as we change our day one day at a time, we see that the sun is always on the ecliptic. It's slowly moving bit by bit along the ecliptic from left to right. It looks like the ecliptic is changing position, and it really kind of does relative to the other stars, but the sun works its way down this path. And it makes it all the way around this red line in a 360-day year. It just moves a tiny little bit to the left every single day. So it drops down and follows that ecliptic path every single day. And so that's what we're seeing when we watch the sun move. It slowly moves bit by bit along the ecliptic. Remember though, this is just what the sun does day to day. If you look at the sun's path throughout a day, right, we can see that it moves left to right, just like we would expect, or it moves east to west. So, one more time. In conclusion, just so this is nice and clear, the ecliptic is the path that the sun takes throughout the year, not throughout a day. Every single day, the sun moves slightly to the left or to the east along the ecliptic, about 1 degree to the east along the ecliptic every single day. On any day, it moves east to west, but every day it moves slightly west to east. I know that's confusing. Hopefully this tutorial helps a little bit. But again, every day the sun moves slightly west to east along the ecliptic. We'll explain why in our next unit, but for now, just understand that that's what it does, slowly moving west to east along the ecliptic. All right, thank you. Hopefully that helped.